coming to tonight's program, he then is a professor and deputy director at Research Center for Brain-Inspired Artificial Intelligence and director of the China-UK Research Center for AI Ethics and Governance, both at the Institute of Automation of the Chinese Academy of Sciences in Beijing. He is the board member for the National Governance Committee on Next Generation Artificial Intelligence of the Ministry of Science and Technology of China. He is the director of the Research Center on AI Ethics and Sustainable Development in Beijing. He is one of the major drafters for the National Governance Principles of New Generation AI in China. I want to thank Yi for joining us from Beijing. It's morning in Beijing. It's in fact Friday morning. Zoom is a bit difficult to use from China, so hopefully everything will go well. I just learned that Zoom uses a server in Germany, so everything Yi says is bounced from Europe. It has a little bit of echo, but hopefully it will be okay. Now, stop share. This way we can see each other very well. Okay, Yi, share the screen. Tell us what you do.
Okay. Here, can you see my sharing?
Yes. You want to put it full screen?
Yeah. Now I'm in the presentation mode. Does it
Perfect.
work?
Yes. Okay. I'm going to remove my video and my audio so I don't interfere with your presentation. Okay.
Okay. Thank you. So good morning and also good evening. Also for those, good afternoon. It's a great honor to be invited to the session here. So it's really a great talk to connect life science and art and technology together. And I'm trying to have different perspectives to investigate on the topic from our session's point of view. So my topic for today is creating brain-inspired AI for human AI symbiotic society. So let's still go back to where we are so that you can have a clear vision on where we should go. So basically, I think I would classify the current AI as mechanism-based AI and also data-based AI. If you think this is really the data-intensive information processing can be called AI. So basically, what I think the current AI is doing is that you have larger scale data, and then you have the expected output. You find a mathematical optimization method to map the input to the output. But the mechanism for process those information could have nothing to do with intelligence, I would say. Well, there's another approach that I call mechanism-based AI. That is really to get inspirations from the nature and really to learn about the natural evolution and really to get intelligence right after this kind of approach. So they're totally, I would say they're totally different. So maybe you think, well, maybe not that different. So let's see why it is different from a current application point of view. Well, it's like a year ago that in China that there is a report saying that for those food delivery giants, so they develop something called a super brain, which can actually do the planning for the food delivery riders, so that it's not only giving them more opportunities to get money, but also to help them to for the path optimization. So it's called the super brain. But the real case for now is that the food delivery riders were trapped in the AI planning algorithm for now. It happens like weeks ago. So basically, the idea is that you have to deliver your food in a quite limited time amount of time. So now, if 90% of the riders could do it in 30 minutes, so you should do it too for the rest 10. And then if everybody, so you have to be in a rush. And then if everybody can do it in 25 minutes, so this algorithms will push you to 20 minutes. So the basic idea is that if others can speed up, so can you. Otherwise, you will be punished money-wise. You lost £1, let's say. But if you really do it, you could die because you need to go against the traffic rules and just to save time so that you will not be punished. So as you see, that in the middle and the bottom, there's a Chinese. I will translate them to you. It says that for those food delivery riders, please don't send the food using your life. So for the current AI system, it does not really understand what does it mean for speeding up for drivers. And they don't really care if the drivers are against the traffic rules, which may kill them, of course. And also, they do not know what it means to kill people. They do not know what does it mean for people. So this is the current AI systems that try to pretend to understand and try to process those information, do optimization to the expected output. Well, the output is not what we expected. It kills people. So this is why I feel this is really not okay to leave AI as it is, as a information processing system that seems to be intelligent, but it's not. So it's like more than 20 years ago that Nobel winner says that we had to be quite sure that the purpose we put into the machine is the purpose which we really desire. I think we need to think about the current status that we have a machine that processes information, but we do not have a machine that understands, really. That when you go into the field of natural language processing, they seldom say natural language understanding, or they use the word now, but actually you see statistics right there, but you cannot see real understanding right there. So, but if you want to understand, do we really need thinking before understanding? So that's my general question. And can the current machine really think in that case? So when talking about can machine think, actually, when people learn about the idea, 1950 or around, by Edmund Berkeley and also Turing, and then it's like 5 years later, they have the Western Joint Computer Conference, a session on learning machine, organized by Willis Ware, and then people are having discussion on, well, if the machine can think, well, at first it has to learn. So people are talking about pattern recognition, machine learning. It's a starting point. But I think it's not really that only about learning, of course. So the intelligence is shaped in a very interactive environment for billions of years, I would say. So starting from learning in sec, and then going for development for years, for decades, and then through billions of years of evolution, that we get our brain as it is for now, and it's still evolving. So we have different versions of the brain, which is of course very diverse to each other. But really, if you want to build a machine, I would say if you want to build the real AI, it's really a transdisciplinary research. Neuroscience, cognitive science, psychology, complex system, developmental biology, even philosophy and ethics related to the AI part. So my approach would be really that I feel the safest way is to really build a biological realistic AI that you got inspirations from the brain and cognition, and also the structures, and then to build the building blocks in this way, as bottom up and top down, and to really get a brain-inspired AI that uses these building blocks, but with emergence to these different cognitive functions, and how they self-organize together to solve the problems that you never see. But from the behavior level, it has to be similar to human, so that as a selfish human being, that we want them to, interact with us in a way that we expect them to be, so that we're more safer. Well, when you think that, okay, what if we just stay in the information processing part that seems to be intelligent? Let's see another example besides the food driver trapped algorithms part. That when you change one pixel in these pictures, and then if the pixel is really critical, you'll get like for the airplane, it will be like, or 99% 99, it's a dog. And also for the truck, for the frog, it says, well, that's a truck, of course. So that's why I feel, this is why I feel that these information processing tools is just doing something that seems to be, pretend to be intelligent, because your training data should be really ideal, no noise, to describe the real world in the best way. And then by using this data, you could train a model that understand the so-called real world. But the real world is not without noise. So well, of course, you can build an AI model that's handle noise, but the problem is not really that, because our brain is shaped in the natural environment through evolution. So it's not that we design a function to handle that. The functions really emerge from structures and mechanisms as well as their synthesis. So when we learn to build a neural network that can do pattern recognition and memory at the same time, well, because traditional neural network cannot have concrete memory. Let's say when you learn hand-digit recognition, but if you ask the network to recall the 10th image that it saw, it cannot. So they don't really have concrete memory. So we're doing but it's a coincidence that we found if we introduce different percentage of the noise to the system, and as you can see, let's say for 50% of the noise, the convolutional neural nets get to 20% of the accuracy. Well, there's another version called capsule network from Jeff Hinton that goes for 25% for accuracy when introduced noise. But our network keeps 80% for the accuracy when noise are introduced. It's not that we're having a better network. I think the beauty part is that we do not design a function to handle noise. It's really that when you simulate at certain levels of detail for the hippocampus, that it can do recognition, and also it can have concrete memory. Or at the same time, by evolution, the structure of the hippocampus enables you to handle noise. That's something that I feel important. So it's really not. I don't think. It's really that I don't think that when you're having a much efficient and also much efficient algorithm that have best accuracy is the core part. The core part is really the adaptation, as everybody is saying from from Darwin to Herbert Spencer. So that's the core of intelligence, the most adaptable to change. Another angle is that if you really want to build just like an information processing machine, there are multiple intelligence that you have to think about. From general, very different type of sensation to different type of memory. That's the basis for different type of learning, and also for decision-making prediction. But the essential part is how you organize, self-organize them together to solve very different tasks. So the brain is a synthetic model to really organize these very different cognitive functions together. So that's, you see that my robot is helped to clean my door, clean my table, to reorganize those toys and to just throw out the garbage. And there's another one to wipe the blackboard. So they're designed with all of them are implemented by spiking neural network. But still, this is something that is just doing something that seems to be intelligent. Well, I don't think it's really not. I don't think it's really intelligent. Or I'll give you some reason later, but the important part for now is that many of the AI researchers is really proud of what we can do for now, but I don't, although I'm still an AI researcher. But when you sort out the things in cognitive science, in psychology, well, you will get more than 20 different cognitive functions from different versions of the brain, say, from different biological intelligent beings. Well, for AI, maybe you only have, let's say, 20 for them. Well, that would be the best, I guess. But the core part would be that really for future AI, that where are we headed for? I would say that it's not only that you need more cognitive functions. It's really that how these cognitive functions are self-organized together to solve problems that you solve or that you never see, and in a self-organized way. And also that when creating a more intelligent, more general intelligent beings, that we need to evaluate them from different angles, from multiple intelligence. So this is why we're having a cognitive imitation game initiative supported by people from different organizations to really have the right way to evaluate intelligence. Not really to create a information processing system that only can do the best at one angle without self-organization, without multiple intelligence. So let's go back to the question, can the current machine really think? The question will, of course, be brought by these wise people. But still, when you think about the question from the angle of I think, therefore I am, well, you never say you think, therefore you are, because you're in my perceptual bubble. So similar things could happen to a machine, that I think they are still in our perceptual bubble, as long as the machine, so-called machine, is with a sense of self. In that case, I would believe the machine can think. Well, talking about self, of course, many levels of self-consciousness is the core part. Let's talk about self-perception. So for the mirror test, these animals are believed to be with self-perception or an initial level of self-consciousness. So because they can pass the mirror test, from chimpanzees to elephants, Asian elephants, into orcas and dolphins, but not monkeys. So my colleague at Institute of Neuroscience in Shanghai, that they trained rhesus monkey to pass the mirror test. When the monkey could pass the mirror test, they would just turn around and to use the mirror as a tool to see, oh, what does my asshole look like? So at that time, you could identify, oh, this is really that they understand what does it mean of a mirror and what does it mean of you in a mirror, because they're using the mirror to complete their model self. Well, the inspiration for me is that if this really can be trained, I'm not saying they're doing the good, they're doing the right thing, but just think about the scenario. If it can be trained, well, why a machine cannot? So this is another experiment that I did on with the robot and our brain simulator. Well, I would say a cognitive simulator. It's not a whole emulation of the brain. So at first, these robots cannot identify which one is themselves because all of them have hands. They have some outline study because when they're just doing random movements outline without a mirror, they will learn the associative relations to those hands and foot to their to themselves. And then in front of a mirror, that you have 6 hands, so they're not quite sure which one is theirs. So by visual and tactile associative learning, they activated the brain areas called insula, which represent the abstract self. And then they could identify which one they are. So all of them are still built by spiky neural networks. We don't really have time to go into the detail for the model for today, but that's the basis because this is really critical to use that because the biological plasticity principles in the brain is really that within approximately 80 milliseconds, that the 2 neurons are associated together, that fire together by time-dependent plasticity. Well, if you just exceed the range of the time, it doesn't really relate it. That's how the brain compute the relations, the associations. Well, of course, you cannot say if a machine, and then I was well, last year when I was in Puerto Rico having a conference called Beneficial Artificial General Intelligence organized by Max Tegmark. He said that there's a cognitive psychologist from Cornell saying, you just changed what I think about self-perception because when I was a student, people told me in the textbooks saying that this is the golden standard test for self-recognition and also certain levels of self-consciousness. And then you say machine is with self-consciousness. And I was like, no, I never said that. What I said is that a machine without self-consciousness now that pass mirror test. So that means the mirror test cannot be a golden standard test for self-consciousness. What it's really about is that it's about self-recognition, a very initial stage of self-consciousness. We have a plan to really to build a robot that is self-conscious. But I think if I can do it one by one, I can finish one by one a year. I would expect to have them within the next 20 years. It's really challenging. Taking one as an example, that when you have self-perception, you understand what we mean by self, and then how about seeing others as agents like you? You can distinguish yourself from others, and then to having empathy for others. So that in cognitive psychology was called theory of mind, or cognitive empathy, or 2 types of empathy that we have. So if you're not familiar with the Sally and Ann test, it's that two girls, and then the girl with white hair put the bread in the basket, and then just left. The girl in dark hair, and then just moved the bread to another box, and then the white hair girl go back. So the question is, what does the white hair girl think? Where is the bread? So if you're above 2.5 years old, you'll say, oh, it could be, she would think that the bread is in the original basket. Well, if you're under this age, you'll say, well, of course, she will think that the bread is in the box because the bread is in the box. Well, because before that, you don't really have the strong mind to distinguish yourself from others. You cannot infer from others' perspective. So DeepMind built something called TomNet. It says that we don't need self-experience, and then we can achieve cognitive empathy. Well, for me, it's that if it's without self-experience, how can you say this is state of mind? How can you say this is cognitive empathy? It's just a mapping. It's just a classification. So this is why when building cognitive empathy, that what you really need is really to have the robot to have self-experience. I just want to stop the audio so that we can still talk. So basically, when we build the brain-inspired model for cognitive empathy, we got inspirations from how the brain really is doing. As you can see, for the multiple brain region coordination network, that at MPFC, you could have others' belief and self-belief. And in other areas, it helped to inhibit the self-perspective, so that you can infer from others' perspective. So we don't really have the time to go into the details, but the idea is that for now, the robot, when it has experience, and then when he is facing another robot, he could infer what others' robot is thinking by using this brain-inspired field-mind model. So why does that really matters? Does it really? But when a robot can infer what others thinking, so that's high. That's to some extent a higher level of self-consciousness. So when you build self to AI, is it too risky to humanity? But my idea is that intelligence without the self is the most dangerous approach for AI, because with self-recognition, motivations and values, and also distinguish yourself from others, having empathy for others will keep AI much safer. The way that I want to build the brain-inspired AI is really that I don't want to use the word machine, because it's not only an input and output processing system. It's really that it's really depends on how you perceive AI. Is when you want to build an artificial being, artificial becoming, thinking about the life perspective. Of course, reproduction is important, but more importantly, I would say adaptability in development, evolution, for self and levels of consciousness, and many more are the important essential characteristics of a living becoming. So this is why we need to investigate from the computational perspective on how the brain evolves, and to reveal and explore the origin of intelligence, and also to discover the evolutionary principles, computational principles of intelligence. and also to predict the evolutionary trends of intelligence. This is the different versions of the brain at certain levels of details that we built. Many of them are very rough, like for the human brain. It contains 246 brain areas coordinating together, but right in there is only spiking neurons. Well, for the rodent brain, it's more precise. It's with microscale reconstruction on the connectome, but that's recreating the structure of the brain is not what we want. What we need is to reveal the evolutionary principles and learning principles right embedded in these architectures. Talking about the step forward, when you have the self-perception as a basis, then you get cognitive empathy. That is the basis for a altruistic becoming. That's through evolution, but you got more altruistic behavior in different versions of the biological beings. But what about a machine when it has cognitive empathy as a basis? Let's go into the scenario in here that at the first line you have a green dot have free explorations, and then it would find, okay, when I go up and left and right, I could die because that's water. And then you give them a goal saying that, okay, maybe you need to go from destination A to B and save times. Well, in this case, there's another agent emerged, the red one. So those agents are forced to move a step forward a sec. So in this case, if the green dot go to left, then it will block the way for the red one. In this case, the red one has to go into the sea, has to go into the water. Well, in this case, if you're having the scenario in the left, that's something happened to a information processing system, the current one. But when you have a cognitive empathy component developed on the basis of self-perception and self-experience, that's on the right part, is that the green dot will infer if I go to left, and then the red one will be pushed into the water. And I've been having an experience like this because if I go upstairs or go left and right, I could die. So in this case, without training, without reward, the green dot could choose another path, although it will get a little negative impact to his behavior because it costs a little bit more time. But at least I would say the behavior that seems to be related to a little bit on the ethics part emerge from this kind of system. So humans are vulnerable. So this is why actually, as a human being, that we discover something called ethics, just to protect the vulnerability of human beings. When you have this kind of a basis, the machine could die, they could be hurt. So when they have the self-experience, well, they would learn something, even you don't tell them. So this is why I feel in this way that I think this is the way that we get understanding, that when you have the sense of self, and then to perceive the real world from the self perspective, to understand others and yourself, and to infer others' behavior and actions and to think from their perspectives, and to behave from your perspectives. So we're having the future like this. The machine is doing humanization, while the human are doing mechanization. Well, the future is really what I call the super intelligence conscious living becomings. Well, the philosophical question would be different, because for the machine part, we're talking about who they are, and we're answering the question and building them. And for the human part, we're always asking who we are. And now you have something like brain-computer interface to fundamentally change the way that you are interacting with the environment. I cannot say that's augmented intelligence. I'm not quite sure that when something was augmented, is there anything that has been changed? But really, that we're moving in that direction. So human will also be super intelligent. Well, but these are two very approaches, but could learn from each other. But the philosophical question will be new, because the super intelligence living becoming will be a new we. So I would like to summarize the motivation for brain-inspired AI, as we've been exploring, is really that we're developing a conscious, intelligent living becoming through brain-inspired mechanisms, operational principles. And these living becomings are really sensing, interacting, and changing the world in human AI symbiotic society. We'll explain that later, but it's just like in the Blade Runner saying designed to be more human than human. So it's not a human emulation, because as my friend says, that he said that, well, humanization of AI that you go is really problematic, because the humanizing AI that he thought is the incorrect direction, because the desire, emotion, and values are the basis of eccentricity, discrimination, and hostility. And AI that mimic human nature and human values is dangerous as human beings. He thinks that humans are the most dangerous animals in the world. But I was like, so this is why we call it brain-inspired intelligence, that we hope that if the altruistic behavior emerged from evolution, that we want to minimize that part. We got inspirations from that part, but definitely you don't need emulation of many of the negative emotions, but you cannot really guarantee you win, because the network is evolving. So this is why we really that at any time we need to secure ourselves by not going to the wrong direction, because someone said that, well, if you want to get artificial general intelligence, you have to emulate the whole brain. But in that case, that part will go with you. But I'm not really positive for the destination, saying that super intelligent could be safe. But I just want to say that if through evolution, that many of the altruistic behaviors are minimized, and then if it's really the destination for super AI, the altruistic behavior should also be maximized. I'm sorry, but it's in the process of maximization. So I would be positive for the final part, because if it's not really with maximized altruistic behavior, that's still in the process, but we could die between. So that's why well, there are many reasons that could force us to die, not only for the models, but what we do. Thinking about the heat spot, that so it's just I think it's just a camera, not a robot. And then, but they have the behavior like this: give me a ride, and then people will ride him or her, and then to take pictures. People love them, but it ends in Florida like this. Right on the web page of Teachbot, it says, "My love for human will never fade." So it's like in Confucius, it says, what you do not want others to do to you, do not do unto others. The similar things in Jesus. Um, so it's like when I was having my AI courses, the first course, I thank my teacher for the AI course to show the Steven Spielberg movie in the first course. That the question is really that at the beginning it says, if a robot could genuinely love a person, what are the responsibilities of a person hold towards the mega in return? So I feel that AI principles should not only contain rules to design of AI systems, but also to contain principles as constraints for human to interact with intelligent machines. By the harmony part, why I call it this human AI symbiotic society is really that inspirations from the roots of the harmony. That is not only talking about the harmony among self, family, and government, not only about harmony among different races and countries, but the current explanation could be harmony between human and AI. Right in the for the global understanding of AI is quite different, I would say. When you go to the West, you will see that AI could be a tool. Or when you go to Japan, well, they're building AI as a partner. So this is why in the Japanese AI principles, at the last, the final point is that if an AI could be a quasi-member of the society, it has to obey all the rules in the human society. So you see that they perceive AI as a quasi-member, as a partner of the society. Well, if you go to the sci-fi, it will always tell you that we are competitors or enemies. But that part, if they're partners or competitors, really depend on which way we're going for long-term AI and super AI. So we need the right philosophy, the right design philosophy to start to create the conscious living AI. Like I said, it's a conscious living becoming. It's not a being because it's still evolving quite fast, much faster than the human evolution. So that's a living becoming. You cannot only have principles for them, but at the same time, if they're designed with a sense of self, with self-perception, fear of mind, cognitive empathy, all the way down to emotional empathy at last, and then you cannot say, I don't have empathy to robots because they're living becomings in that way. Or that depends. It's really silly to say the current robot needs rights. It's really because for now they're processing information that seems to be intelligent, but they just pretend to be intelligent. It's not that they're with a sense of self. And also, if they are is really a self-conscious living becoming, we should have some bias for them as long as their private information, their preserved information, does not really hurt human beings. We cannot have bias on machine in that case, because you cannot say, well, right in the elevator, there's a machine, there's an AI, or there's me, and then something bad happened. But definitely, that's not the man, that's the robot. No, you cannot do it because similar things, they're the quasi-member of the society. So we need some shared values. So just like what my friend says, humans are the worst animals in the world for now, which I'm not questioning. Well, people have different ideas. many other philosophers doesn't agree with him. But what I want to say is really that's when you go back to Blade Runner to think about to be human and human, I think that's one of the explanations that we could have. It's really that how do we perceive our existence in the universe? How do we perceive the relationship? So I'm gonna end by a Chinese version of the moral machine. That's by my friend Wendell and Colin. So I think many people read about it, but in the Chinese version, at the surface of the book, it says, put the machine into the moral cage. So I asked Wendell, do you really mean it? Wendell was like, oh, I like it. I'll put that into the second version of my book. So I was like, well, in this case, you don't send me your second book because I don't think you could do it. And he was like, why? So I was like, writing 5 years ago, that you have a robot that watch YouTube movie to cook. And then recently people are building robots that try to understand, I would say try to pretend to understand what the movie is about. But 30 years later, or even longer, that you have a super AI watching YouTube on how people treat their ancestors, pre-conscious robots, then who is in the cage? So who is in the moral cage? I would expect that maybe human. So if we stay as we are, so I also don't like the word human being. That means we don't change. We are. So we're human become. So even we have many thoughts on the future possibilities, and we want to secure us. We want to change the current AI, but at the same time we need to change ourselves. So but still that's not enough. We don't know. This is the clue is really that we don't know, and also still that we need to go back. That is why we need to go back to say that we can only see a short distance ahead, but we can see plenty there that needs to be done. With all that, I thank you for your attention.
Thank you, Zeng. I see there's also a question that is similar to the question I have. So let me ask that one first. It's about the body. So your presentation, even the name of your lab, the name of your project, it's brain inspired. But one could argue that if we didn't have eyes, hands, we wouldn't be the same people. So that's one question that I have for you. How important it is to actually simulate the body, the fact that we have the senses that we have. That's one question. So the body. The other question is the opposite. What if, can you make a human brain that is just software, pure software? In which case the interaction with us is not about moving objects. It's about performing things on the cloud.
Thank you. I think both of the questions are fascinating. So I think the emphasis on brain inspired is only that we want to differentiate from the current version of AI, which is data intensive. So the emphasis on the brain part is really want to go to mechanism. So for our nervous system, of course, we have the central nervous system, which include the brain at the core, but we also, like what you said, we have other nervous systems, but for our hand and leg, and how to coordinate them together to really have a more comprehensive intelligence framework. This is exactly where we're going. So this is why weeks ago I emailed you about the cognitive simulation game that we feel is that we need to have multiple intelligence, not only from the brain part. So for the question is definitely right. It's not only about the brain, but the current emphasis is only to differentiate with the with the information with the so-called data-intensive mechanism.
And could you evolve? You call them becoming being. You evolve a software robot that has empathy, and altruism, and so on.
I think so. And so first, like what the second question about is really that it doesn't really matter which way you exist. If you have a body, and then we're having more of the intelligence embodiment, that you experience the world in a hard or soft way. But but when you go to another version that you live in a cloud for those intelligence beings, I don't think that's only a cloud, because there are many things, I mean, Internet of Things, that serve as the sensors for the cloud. So in this case, you cannot say that version is without sensation. They have many sensations, much better than a single intelligent body. So that could be the destination for the super AI.
The other thing, I share your friend Zhao's concern. I mean, there are a lot of very evil people on this planet, and you know, there are human beings who killed millions of people. So that's an obvious concern. I mean, even with humans, we train children. It's not like children are dumped in the forest and they develop their own ethical standards. We teach them, right? So that's a concern. How are you going to make sure that your robot learns to be a good citizen, not a bad one? Somebody has to teach, right? Somebody has to decide what is good and what is bad.
Yeah, thank you for the question. There are many books related to this. So the current one is Human Compatible by Stewart, who you also invited to this wonderful venue. That the basic idea from him is really that you have a group of people that teach what we mean by human ethical values. But if you go to Chappie, the movie, you will see that it was born in a group of bad people, and then he was trained as a bad people. But when he was brought back to his Indian father, he was retrained. He was trying to understand the world again from another angle. So I would say that really that as long as the model is still evolving, we got an opportunity. But if we start somewhere which is not really, the right one, it's really problematic. So this is why I feel we should have some internal build models like cognitive empathy and emotional empathy. That's from evolution. You cannot say you have a random network to start to evolve. In that case, for the billions years of evolution, all the incorrect ways that you go for could happen again. So this is why we need to humbly learn from nature to avoid some of the risks, but you cannot say there are no risks in your model.
So yeah, Lucy had a similar question. She's asking, don't you need a panel of philosophers, sociologists? I would add biologists, since you talk about evolution, to advise you on these things.
Exactly.
So the answer is yes.
Yes.
Let's see if there are other questions here. Are you familiar with the Miller guidelines for the moral development of computer systems?
Mm-hmm. Can the question be more specific? Which part shall be discussed?
And if you're not familiar, we skip to the next question. That's okay. She says that Miller came up with a number of guidelines in 2011. How do you decide between the level of detail of your biologically plausible model versus computationally efficient abstraction for engineering an actual system that works in the real world?
Thank you. The question is brilliant. So actually, it's really that it's about the levels of details that you need, and that counts. For me, it's like, well, many people think that, well, there's a panel last year for the conference that I mentioned in Puerto Rico that right there is a panel called Passes to AGI with me and also Joshua Banjo and Josh Tenenbaum and Nick Bostrom. And then Joshua was like, he perceived all the panelists as efforts at different levels of details. He himself is in the, I would say, in the AM model with the high level abstraction, where I built the model by spiking neural network with ion channels in the model with spike time independent plasticity, synaptic models, because I think, like the mirror test, if you don't really have the biological constraints of 80 milliseconds, it will be hard to decide. It will be hard for the robot to design, to evolve, to have similar behavior. Although you could learn the parameter, but that's not the way the human is doing. So I think talking about the levels of details, if you want to have the final destination, you should be really careful which part is not really useful. I will give one very concrete example, and very interesting, is that when we build the Hodgkin-Huxley model for those spiking neurons, so I blocked some of the calcium channel. The learning system is still learning, but it slows down. But when you block the potassium channel, it's just stop learning right after you block the channel. So that means even at the ion level, that they contribute to cognitive behaviors in quite different ways. So that if you want to build an application, the levels of abstraction could be decided by what you need. But for the future AGI, you could have different way to implement these details, but it seems that some of the details cannot be really, just that does not exist in your system. It's not that simple. There are many things that we don't know. So the answer could be that still, now many hypotheses says that our brain is a quantum brain. If it really is, then for those microtubes in the neurons, that's the core to implement the quantum phenomena, or in that to implement the uncertainty. So that's why we also have something called quantum spiking neural network. Well, but that's beyond today's focus. So that's the question is left open, I would say.
Right. One thing I like during your presentation, at one point you mentioned, just in passing, that the machine should learn, even if we don't tell the machine to learn.
Yeah.
And that's what every animal does, not just us. You don't need to tell a cat, hey, you have to learn what the mouse does. The cat learns it automatically, right?
Right, exactly.
So where does that come from? How do you tell a machine, hey machine, you have to learn?
Right. I think this is also can go back to the brain predictive learning, that we're not perceiving our world, we're predicting our world. When you go into a room, you'll say that, well, for me, Now I'm in Pierre's room. I don't see the contour of those bookshelf, but I know that's a bookshelf. I don't see the detail for that door because I'm predicting it's a door. So I have some prior knowledge, which could be some memory from the past, and then I predict the real world. But something could be really different that is far away from your predictions. Then the biological evolution shape the brain to minimize the difference. So, so the brain, even the AI brain or the biological brain has a mechanism to for the gap minimization. So that's where the learning come from. So still, by the AI brain, still it's a predictive brain.
So I see I'm going through the questions. I just saw there are some questions also on the chat. I think there are still concerns on how you teach a machine to be good. Nicole is asking who is the mentor, who's going to train this machine. By the way, in the case of humans, it takes years. I mean, you have to teach, punish, whatever, your children for years, teenagers, young people. We have prison, justice, police, you know, it's not so easy. So that's one question. And then I forget the name. I think Gregory was saying, be careful, because the human brain is not designed to be the best possible architecture, just designed to survive in the world. It developed more or less accidentally based on our environment. What makes you think is the ideal goal?
Thank you. Exactly, I agree that during the process of evolution, the evolved part is really that's all accident. But as an evolutionary system, it's going to the direction for optimization. But we cannot say human beings are the best optimized. So still, things will happen to a machine. You cannot say that's the destination. They're still in the process of doing it. Coming back to but when you go to the human brain, if they have a choice, they don't. If they have a choice, people think, well, many people think that the neocortex can do everything, but still, the biological brain left some of the cognitive functions, such as reward part, still in the midbrain or in the old brain. So that's something that brought by evolution. You cannot just throw them away. So it's not really optimized at the end. No. Similar things could happen to AI. So they are not the final god. They are also in the process. Going back to the training part, I cannot agree more that there is a article on Scientific America years ago talking about developmental robotics. There's a scientist from Japan saying, the journalist says that, do you really believe that you can build a robot child? And then the answer would be like, well, it depends on how you treat the robot. If you can treat the robot just like how you treat the child, I believe we can understand the nature of development, and also we can build developmental robotics. Otherwise, I see no way. So that's what he says. But really, it's about that. You could have a really naughty AI, but in that case, we hope that we just lock them on the cloud. We're not sure whether we can, but really that you need to have this kind of empathy and time to interact with them. Just like, so that's why I actually like the movie by Steven Spielberg. But I think that the human being just failed in this film in a way that they just give up the chance to.
Okay, it's been over 1 hour, so it's time to let you go. The last question, I think it was Catherine was asking a question. Was keep it for the end because it's a personal question. What caused you to start this kind of research? Did you have an experience with existing AI systems that traumatized or that enlightened you and started you doing this research?
I think still going back to the movie and a Chinese character. The movie start with an engineer scientist saying that I want to build a robot that can love. So I was like, yeah, that's my profession. We need the future AI that loves. And then, so that's why I'm choosing this as my career and as my profession. When you go into this profession and you see that when people are building something that can make profits, that seems to be intelligent, but it's not, way behind, it's too far to the robot, that the AI that can love, then you need to make your choice to go for another direction. So then the Chinese character is that when I talk to some government officials in China, some of them don't really have a technical background, but when they see the character AI, the Chinese, we have pinyin. It's quite similar to the English characters. And he said, well, AI in Chinese, that means love. That's I. So I love you. That means it's in Chinese. It's 我爱你. So I means the AI means love. So to me is that really that AI what AI is really about is to love humanity, love the future, and to love the human AI symbiotic society that guide us to.
On this positive note, I think this is a good way to end. Thank you very much, Zeng, to join us from Beijing. The audio was good, so everything went well. Thank you very much. I hope we can continue a conversation in the future and talk about loving robots and being loved by robots. That's a very nice way to end this conversation. Thank you, everybody, for joining us tonight. Go to lasertalks.com if you want to know about the next dialogues. Thank you again, Yi, for your wonderful presentation.
Thank you so much, everyone. Appreciate the invitation and all the interactions with you. Thank you.